Hello, everyone, and welcome to today's lecture on Introduction to Organic Chemistry. Organic chemistry is one of the most important branches of chemistry because it deals with compounds that form the basis of life. Everything from the food we eat, the medicines we take, the clothes we wear, and even the fuel that powers our vehicles contains organic compounds. By the end of this lecture, you will be able to define organic chemistry, understand the characteristics of organic compounds, classify organic compounds into different types, recognize common examples of each type. Let's get started. So what is organic chemistry? Organic chemistry is the branch of chemistry that studies carbon-containing compounds, especially those containing carbon-hydrogen bonds. The term organic originally referred to substances obtained from living organisms. However, scientists later discovered that organic compounds can also be synthesized in laboratories. Today, organic chemistry focuses on the structure, properties, composition, reactions, and preparation of carbon compounds. Examples of organic compounds are methane, ethanol, glucose, and acetic acid. Carbon is unique because it can form four covalent bonds, allowing it to create long chains, branches, and rings. Organic chemistry plays a major role in many fields. In medicine, organic chemistry can be seen in antibiotics, painkillers, and vaccines. In agriculture, it can be seen in pesticides, herbicides, and fertilizers. In industry, it can be seen in plastics, synthetic fibers, and dyes. And last but not least, in daily life, it can be seen in soaps, cosmetics, and food additives. Understanding organic chemistry helps scientists develop new materials and improve human life. Organic compounds can be classified into several categories based on their structure. They can be divided into acyclic and cyclic compounds. We will start with acyclic or open-chain compounds. These compounds contain carbon atoms arranged in straight or branched chains. Examples are methane, propane, and butane. Characteristics of acyclic compounds are as follows. Carbon atoms form open chains, can be straight or branched. Relatively simple structures. Next, we look at cyclic or closed-chain compounds. These compounds contain carbon atoms joined together to form rings. A good example is cyclohexane. Characteristics of cyclic compounds are as follows: ring-shaped structures. More stable than some open-chain compounds, common in many biological molecules. Cyclic compounds are further divided into homocyclic and heterocyclic compounds. Homocyclic compounds are cyclic compounds in which rings contain only carbon atoms. Examples are benzene and cyclohexane. The second type is heterocyclic compounds. These are cyclic compounds in which rings contain carbon and other atoms such as nitrogen, oxygen, or sulfur. Example are pyridine, furan, and thiophene. These compounds are very important in pharmaceuticals and biological systems. Another important classification is based on bonding and structure, in which organic compounds are subdivided into aliphatic and aromatic compounds. Let's start with aliphatic compounds. These are open-chain or non-aromatic cyclic compounds. Examples are methane, ethane, and propane. They are further divided into 1. Saturated hydrocarbons, also called alkanes. Alkanes are open-chain compounds containing only single carbon-carbon bonds. Common examples are methane, ethane, and propane 2. Unsaturated hydrocarbons, also called alkenes. Alkenes contain double or triple bonds. Unsaturated hydrocarbons are divided into alkenes and alkynes. We will start with alkenes. Alkenes contain at least one double bond. A common example is ethene. Next, we move on to alkynes. Alkynes contain at least one triple bond. A common example is ethane. The second classification is aromatic compounds. Aromatic compounds contain benzene-like rings with delocalized electrons. A common example is benzene. Characteristics of aromatic compounds are as follows: highly stable ring structure, distinctive chemical behavior, important in dyes, medicines, and plastics. Other examples are toluene and naphthalene. Now let's talk about another vital, if not the most vital way to classify compounds in organic chemistry: functional groups. A functional group is an atom or group of atoms responsible for the characteristic reactions of an organic compound. Some common functional groups include alkane, alkene, alcohols, aldehyde, ketone, carboxylic acids, amine, and ester. Functional groups help classify organic compounds and predict their chemical behavior. That concludes today's lecture on Introduction to Organic Chemistry. Here is a summary of what we covered today. Let's quickly review what we learned today. Organic chemistry is the study of carbon-containing compounds. Carbon's ability to form 4 bonds makes it the foundation of millions of compounds. Organic chemistry is the study of carbon-containing compounds. Carbon's ability to form 4 bonds makes it the foundation of millions of compounds. Organic compounds are classified into acyclic, open chain, cyclic, closed chain, aliphatic, aromatic functional group-based compounds. Functional groups determine the chemical properties and reactions of organic molecules. Thank you for watching this lecture on Introduction to Organic Chemistry. If you found this video helpful, please like, share, and subscribe to the channel for more chemistry lessons. Feel free to leave your questions in the comment section. See you in the next lecture. Happy learning!